So as you know, this course will be taught in two methods. The first one is theoretically, and another one is via laboratory assessment. So I will be Dr. Arif will be teaching you the theoretical part, and I will be teaching you regarding the the laboratory. Okay. So basically, this is what the thermodynamic laboratory is all about. So what is thermodynamic? So thermodynamic is actually a name combined from a big word for heat, refer to thermos, and power, referring to dynamos. So it is being coined by a British scientist called as Lord Kelvin in 1849. So basically, the science of thermodynamics was born in the middle of 19th century to describe the operation of steam engine and their limit of operation. So why do you need to study chemical engineering thermodynamic laboratory? This is because thermodynamics is actually the science of heat, works, and its related property. So thermodynamics is actually the basic science that deal with energy and is also study the movement of energy. Furthermore, in today's equipment, there is a lot of machinery or equipment that are using principle of thermodynamics such as steam turbine, refrigerator and heat pump, compressor, boiler, condenser, as well as cooling tower and heat exchanger. So in thermodynamics, there is two methods of studying. The first one is classical thermodynamics and another method is statistical thermodynamics. So in this chemical engineering thermodynamics, the scope of study is we are going to study the basis of thermodynamics, which is its experimental observation. Okay, so based on this experimental observation, this finding will formalize it into certain basic law, such as Zill's law, first law of thermodynamics, second law of thermodynamics, third law of thermodynamics, and so on. Okay, so thermodynamics deal with equilibrium position, and then thermodynamic or consideration do not establish the rate of physical or chemical process. Thermodynamic is a macroscopic property formulation. It cannot reveal the microscopic or molecular mechanism of physical or chemical process. So, in this chemical engineering thermodynamic, this will be the scope of study, okay, which is the first law of the dynamic, the second law, the third law, and so on. So, in conclusion, if everything is so simple, okay, in thermodynamic, why does thermodynamic have the reputation of being one of the hardest course in university? It is simple. This is because chemical thermodynamic laboratory, it involves a lot of hard work and science and number and not very entertaining or understandably looking. Okay. And then furthermore, the difficulty comes from making precise description of phenomena and in developing a mathematical framework that allow the use to cultivate an understanding of the thermodynamic law. Okay, this is the laboratory planning for the chemical engineering thermodynamic for this semester. First of all, you will be share with the videos of how the lab is being conducted, and then after that you uh, will be distribute with reading materials to enhance your understanding regarding the labs. Afterwards, after you finish your readings and video, you will be given practice exercise to measure your understanding regarding the laboratory experiment. And then last one, you will going to go through or being given an assignments so that it will further enhance your understanding and further deepen your knowledge regarding this each of the experiment. So the estimated time of every lap is about 2 hours and 50 minutes for your time. Okay. So this is the details of experiment that we will going through for the whole semester. The first experiment is the characteristic behavior of a two-phase fluids. The second experiment is the combustion unit. The third experiment is the miniature steam power plant. The fourth experiment is the vapor liquid equilibrium or VLE. And the last experiment is experiment 5, which you will be going through the bomb calorimeter. For experiment 1, okay, I will explain a bit and giving you the experimental background of what each experiment is really about. Okay, so basically the experiment 1 is like the previous slide mentioned, is the characteristic behavior of a two-phase fluid. So in this experiment 1, we will dive deep into two-phase flow phenomenon occurs in various industrial applications such as aerospace, automotive, nuclear, oil and gas application. So due to the unavailability of classical equation to determine the complex flow behavior associated with two-phase flow, it is important to predict the characteristic behavior of this type of flow. The complexity increases when flow direction changes due to varying interfacial stresses and unstable phase distribution in the flow domain. Among different applications, curved pipe or elbow are commonly used in heating and refrigeration systems to transfer heat from one fluid to another. The pressure and velocity distribution at different spatial locations of the piping system are critical for effective heat transfer, mixing, and circulation. Single-phase pressure drop can be predicted with reasonable accuracy for curved pipe. Prediction of two-phase pressure drop in curved pipe and vent is quite complex due to differences in fluid density, viscosity, phase transformation, and their interaction with the surrounding wall. So this is a little bit of experimental background regarding experiment 1. So what is the objective of experiment 1? The objective of experiment 1 is to study the behavior of water during the transition between liquid and vapor phases. The second objective is to investigate the behavior of water at temperature around the vapor point and over the range of pressure. The third objective of this experiment is we want to study the change in vapor point with increasing pressure and to observe the fluid behavior using a slide glass set into the pressure vessel. Okay, the learning outcome for experimental 1 are as listed. Okay, at the end of this experiment, students are expected to be able to measure the saturation pressure of water using a pressurized vessel. The second learning outcome is the student must be able to examine the effect of unsteady condition on measurement accuracy. The third outcome, student must be able to acquire knowledge on the behavior or level of water at temperature around the vapor point over a range of pressure. Analyze the change in water point with increasing pressure, and the last outcome is to produce good technical report according to the required standard. Experiment 3, which is the combustion laboratory unit. Okay. Combustion laboratory unit is floor-mounted designed for for students to study many aspects of combustion using a small-scale unit, which will be easily understood and controlled based on industrial dual-fuel burner. The unit comes with the burner, combustion chamber, control panel, and instrument at all convenient working height. Students shall vary the fuel and air flow rate over a wide range and the effects on flame characteristic and combustion efficiency may be reduced. With a flue gas analyzer, the composition of the fuel gas may then be determined and related to the air to fuel ratio. So basically, for this experiment too, the objective are as listen, to determine the type of flame at different air or fuel ratio. The second objective to determine the product of combustion at optimum air or fuel ratio. And the last objective is to determine the heat transfer balance for water in and out. So the learning outcome for experiment 2 is the student must be able to acquire an understanding of combustion process and then run the pilot scale combustion unit with optimum ratio of air to fuel. And the last learning outcome is the student is expected that a student is expected to analyze heat transfer based on different type of combustion. So we will further proceed with experiment 3. So experiment 3 is about to study a miniature modern day power plant for educational purpose. So we know we normally saw a real scale power plant. However, this power plant is being designed to simulate the real power plant for educational purpose. In this power plant, a pump supplies water from a feed tank to a small gas-fired boiler. The saturated steam and then can be heated by an electric superheater, which is optional. The steam is throttled to a single-stage engine. Exhaust from the turbine is condensed in a water-cooled condenser. The condensate is collected in a graduate beaker and returned to feed water by a pump. Lastly, a small DC generator is connected to the turbine by a valve and electricity is applied. A mechanical dynamometer is also provided for measurement of the turbine mechanical output. Basically, for experimenting, the objective is to enable students to determine the efficiency of component in a steam power plant. The second objective is to enable the student to determine the heat transfer between condenser and cooling water. The third objective to determine the steam efficiency and plant efficiency. The fourth objective or the last objective of this experimentary is to determine the power generated by the steam engine. The learning outcome is for the experimentary is we expect students to be able to acquire an understanding of heat transfer between condenser and cooling water in steam water plant. The second learning outcome is we expect students to be able to perform a pilot scale power plant of power generation of steam turbine and steam engine. And last learning outcome is that students are expected to be able to examine steam efficiency and plant efficiency as well as their power generation. And then we further venture into experiment 4, which is vapor liquid equilibrium. Vapor-liquid equilibrium undergoes the bulk of industrial separation process, particularly in distillation process. In this module, we will consider only binary two-component mixture. The composition of the liquid phase will be designated by the mole fraction of the more volatile component, referring to lower boiling point, which is being represented by X. The mole fraction of the other component is of course 1 minus X. Likewise, the whole mole fraction of the vapor will be represented by Y, with 1 minus Y being the composition of the other component in the vapor phase. When the liquid mixture is heated to its boiling point, the vapor produced will, in general, have a different composition than the liquid. For example, X can be bigger or X can be smaller than Y. Thus, the boiling point, boiling the mixture produce a partial separation of the component occur. If the vapor is collected, it can be condensed and boil again to further change the composition. Distillation column use this principle effectively, repeating the separation process at individual tray with a column. Such column may have over 100 tray on which VLE is occurring. Depicted at the right is a carton cut away of a small section of a tray-type distillation column. Two sieve trays are shown. Hot vapor, shown in white, flow up through the hole in the sieve tray and rigorously vapor through the liquid, shown in blue. The vapor and liquid mix on this tray and the new mixture boil. The composition of the liquid, referring to X, leaving the will be enriched in the less volatile component, while the composition of the vapor will be enriched in the more volatile component. The vapor rises up to the next tray, where it will be contract a liquid of larger X and mixing and re-equilibration will again occur. The liquid leaving the tray will flow over the well and down the downcomer to the next tray, where it will mix with the vapor on the tray. In this way, X tend to become smaller at each lower tray, while tend to increase at each tray higher in the column. Uh, in conclusion, VLE is referring to the relationship between X and Y value on each tray. So for experiment 4, the objective is that we want students to study the relationship between pressure and temperature of vaporization of a fluid. And then we want students to be able to measure the resulting changes in temperature and pressure. The learning outcome for experiment 4, which is which been designated, is that students must be able to study the relationship between pressure and temperature of vaporization of a fluid, and then measure the resulting changes in temperature and pressure. And the last learning outcome is that students must be able to produce good technical report according to the required standard. And then we go into experiment 5, which is the last experiment for chemical engineering thermodynamic laboratory works. Okay, which is bomb calorimeter. So what is a bomb calorimeter? Bomb calorimeter is a type of constant volume calorimeter used in measuring the heat of combustion of particular reaction. Bomb calorimeter have to withstand the large pressure within the calorimeter as the reaction is being measured. Electrical energy is used to ignite the fuel. As the fuel is burning, it will heat up the surrounding air, which expand and escape through a tube that lead the air throughout the calorimeter. When air is escaping through the copper tube, it will also heat up the water outside the tube. The change in temperature of water allows for calculating calorie content of the fuel. Basically, a bomb calorimeter consists of a small cup to contain the sample, the oxygen, a stainless steel bomb, water, a stirrer, a thermometer, the dewar or insulating container to prevent heat flow from the calorimeter to the surrounding and ignition circuit connected to the bomb. By using stainless steel for the bomb, the reaction will occur with no volume change observed. So the objective of of experiment 5, which is bomb calorimeter, the first objective is to determine the type of flame at different air-fuel ratio. The next objective to determine the product of combustion at optimum air-fuel ratio. And the last objective is to determine the heat transfer balance for water in and out. The learning outcome for this experiment 5 is at the end of this experiment, students must be able to acquire an understanding of bomb calorimeter principle, run pilot scale combustion unit with optimum ratio of air to fuel, analyze the heat transfer between different types of combustion. So we reach the end of our slide regarding the chemical engineering thermodynamic. So basically, for information in the thermodynamic, you must remember the planning schedule for the laboratory. As I will repeat the planning schedule again. It will start with a video showing how the lab should be conducted in real laboratory works, and then I will share with you a couple of reading material for you to go through and deepen your knowledge and further enhance or pillar the knowledge regarding what each the video is really about. And then each reading material will be accompanied afterward with practice exercise to further strengthen your understanding of the previous step, which is the videos and the readings material which I shared previously. And then last one, I will share with you the assignments. This is to ensure that you have already mastered master the experiment which for each experiment. So the assignment will act as a close of loop, which is it will be further and to ensure that you understand the experiment which is being shared with you. So best of luck for you guys for this for the chemical in thermodynamic laboratory. Don't stress out yourself. Just enjoy this laboratory. And this laboratory will start next week. But as I mentioned, it will start with a sharing session of a video showing the actual works of experiment conducted in laboratory. Best of luck for this course, and uh, I end this slide with a thank you for your time and have a nice day ahead. Many thanks. Bye.